We're given the function f of t is equal to the integral from 1 to 2 of 1 plus 5t over 1 plus tx squared dx plus integral of 1 to t of 3 over 1 plus x cubed dx. For t greater than or equal to 1, we want to show that f of t is increasing. Well, the way we show a function is increasing is by taking the derivative. So we have to take the derivative of both sides. Now, taking the derivative of the first integral, we're actually going to take the derivative of whatever is inside the integral. And then we take the derivative of the second integral, and that's when we use the fundamental theorem of calculus part 1, which is just 3 over 1 plus t cubed. Now we take the derivative and get 5 minus x squared over 1 plus tx squared quantity squared. So we just took the derivative of the whatever is inside the integral. And we know that 1 plus tx squared squared and 5 minus x squared and 3 over 1 plus t cubed are positive for x greater than equal for x being in the interval from 1 to 2. Well, we know that anything squared is greater than or equal to 0. And then we know 5 minus x squared. Well, if x is 1, then we have 5 minus 1 is 4. And then if x is 2, we have 5 minus 2 squared, which is 1. So it's going to be between 1 and 4. So this is positive. And then 3 over 1 plus t cubed, we know t is greater than or equal to 1. So you have a positive number divided by a positive number. That's going to be positive. Okay. So we conclude with that the f prime is positive, which means f is increasing. Now the question is f of t bounded for t greater than or equal to 1? Well, from previously, we showed that f is increasing and thus it reaches its maximum in this closed interval from 1 to 2. So we can find a function that is bounded, that is an upper bound of this. And the way we do this is because, well, with the first integral, you want the denominator to be smaller. So how do you make the denominator smaller? Well, you multiply it. You want to have a smaller denominator, basically. And here, x squared is between 1 and 4 because x is 1 to 2. So by eliminating it, we're making the denominator smaller, thus this whole thing is bigger. And then the second integral, we know that 3 over 1 plus x cubed is positive for values for x greater than or equal to 1. So instead of finding the area from 1 to t, we go from 1 to infinity. So that is accumulating more area. Therefore, that's greater. And we know that on the right here, these are bounded because we know that this, by the p-test, converges. So the integral, the area is finite. And this also is finite because it's continuous in this interval. And you can actually find the antiderivative and solve for it. So because this upper bound function is bounded because it's finite, we say that f of t is also bounded.